grouping and things like that. So I'll just do a different class. I'll call mine UJ_chess, and the other class will be called UJ_chess row. So my problem will be based on chess. So I'm gonna open code blocks and then we'll start. So the only tricky part is the UJ board, the UJ_chess row, the UJ board row. That's the tricky part. That's the part that's gonna make your code not compile. And templates also are a bit confusing. So I'll call this template admit. Okay, so I'll call my project templates. Okay, let me just name it P08 templates. And then I'm going to open my main.cpp file. So I'm going to start with for you guys, it's UJ board row. I'm going to call mine UJ chess row. So it's basically the code is the same. I'm just naming my things different so that those who want to copy, they cannot copy and paste. Your code is going to crash. I'm doing this for those reasons because I know some people are just lazy and they want to copy and paste and they're going to get a copy and get a zero, which is a waste of time. So you'd have to implement everything on your own. So UJ_chess row.h, and then I'm going to add it to my project. And then I don't like the underscore included. I'm just going to remove it and then finish. So with templates, right? Templates, remember templates are a way for us to support any data type. Basically, your array can be an array of any type. That's why we make use of templates. It's called generic programming or template programming, whatever you want to call it, but it's like the class is generic. It can take in any type. Where's the settings? Can you guys mute, man? I don't know why people have a tendency to just not listen. Okay. So I'm gonna create the class UJ chess row. So there's UJ chess row. So chess row, I'm going to implement it based on the practical. So the practical, these are the things that are required in the practical. So you need an underlying array size, right? Meaning that it's the how big the array is, and that will be set by the okay. uh, You need the array size of which that will be set by the user. So set by the user, it means that the size will be provided inside main.cpp. That's where the user interacts with our class. So that means I'm going to need a constructor that takes in a size. Whether that's you want to call it rows or columns, whatever you want to call it, but I'm gonna call it columns because my row class has a set of each row. Remember the UJ chess row represents a row. Remember 2D array, right? 2D array. So let's say, for example, you had a 2D array of integers, right? 2D array of integers, it means that, let's say we have a 3 by 3, right? 3 rows and 3 columns. That means, and arrays are 0 index. That means you start counting from 0. Therefore, I would have, let's say these are my rows, vertical, right? And then at each row, I have a set of columns. So that's pretty much the logic behind 2D arrays. It's basically an array an array where where at each index it's another array. That's a 2D array. So at row 0 we have another array. At row 1 we have another array. At row 2 we have another array. So it's a row. It's a one-dimensional array where at each index is a row is an array. So in this case, that means that each row, the array is an array of columns. That's what it means. So since it's an array of columns, I'll call my size calls or columns. You can say int calls like this, that's up to you. That's totally up to you. I like to use unsigned and things like that, but let me just not use it here to make things simple for you guys. So it's going to be called UJHS row, which takes in the number of columns. Okay. Takes in the number of columns and then takes in the number of columns. So that's that's one of the parts we have answered, right? This part. But then we haven't really answered it because they said it should take the size. That means it should be declared privately. So int underscore calls. So this is the size part of the question, right? And then the parameterized constructor, this is the part that we've answered. That's the parameterized one. You see, they said you should have a constructor with parameters and you should have a constructor without parameters. So that means you also need a parameterless constructor. So uj chess row parameter less constructor. And then this would be the parameterized constructor. Okay, there's no way to automate this. Okay. So this is the parameterized constructor, and then so far we have solved this question here, and then we have also solved this, but we haven't implemented, right? Remember implementation, this you'll get the full marks after you've implemented. So far we've done these three parts. We've stored the array size, we've stored the a constructor with no parameters, we've stored a constructor with parameters. We also need a copy constructor. So a copy constructor is simple. So copy constructor, if I want to make a copy, right? I want to make a copy of myself, meaning that it should take in a UJ chess row. So this chess row, I'm gonna call it OBJ right-hand side, because when you use this constructor, you copy from the object that's on the right-hand side of the equal sign. Hence, I'm gonna call the object OBJ RHS, which stands for right-hand side. If you remember your maths, you'll know which is the right-hand side, which is the left-hand side. So when you take in the object like this, we are taking the object as it is. It's like the physical object. So it costs a lot of space, right? So instead of passing the object as it is, I can pass the object by address, meaning that I go to where that object resides or where it stays. It's like, for example, when you go and visit your friend, you go at a specific address, right? So, for example, 42 Auckland Street, something like that. That's where your friend stays. You don't have to your friend doesn't have to like literally leave the house and come to you because they don't have the strength to leave that house, right? To lift it up. It's too big. They don't have the strength for that, right? So I know it's a weird example, but I'm trying to explain why it's important to have the address off. But then when we go to the address, we have the possibility of changing things permanently. So for example, you can visit your friend's house and drink your friend's juice, which is in the fridge, and that person, your friends bought that juice at Woolworths. They used their last mine, and then you go and drink their juice. So you've made permanent changes to where they reside. So to avoid you making changes, because we only want to make a copy. Remember when you go to the UJ library, right, to print to make a copy. Agree, you get the exact same thing as the original without changing the original. You don't miraculously copy from that. Take the original, make a copy, and let's say the original was written in normal text. Now the copy all of a sudden is written in italic. There's no way that's possible. You just copy and paste what's already there. You don't make changes to the original. So I'm going to append a const there to say this should remain constant, even though you have the possibility of changing it since you're taking by address. But then make sure you prevent the user from making permanent changes, for making changes at all. Just copy, work with the values, don't change anything. So I'm going to put a const there. So we have the copy constructor, we've declared it, that's fine. Then we need to overload the indexing operator. But before I index and do all of that, remember this class needs to be a generic class. You see, they said it's a generic class. So that means I need to be at the top of the class. I need to say template. I'm telling C++ that this will be a template. So this is a class that can, basically it's a class that's flexible. Its array, the array of this class will take in any type. So there's many ways you can declare it. You can say class and then call that type T, but then sometimes it gets confusing because you see class here and then you also see class here. Hence, we just call it type name. We just, in other words, it means data type name. What is the name of that data type? I'm just gonna call it T to say that it'll be T, right? So that means my array, if I declare an array in here, it's going to be of type T, meaning that this T is any type. It can be an int, it can be a char, it can be a string, any type, but I'm just gonna call it T. So I'm gonna come here and declare my array. Remember what we talked about. We said that each row, that in a two-dimensional array of integers, at each row, there existed an array of integers because it's a two-dimensional array of integers. But if it's a two-dimensional array of integers, right? Of integers, as always, but we've split it up. We have a class that manages only the column. We have a class called UJ row. You have a class called UJ row.
It's for room. I think the one you can't take it like his hair. Someone is for room. Or like
Hey, Mara, people don't listen. Nah. My patience is running thin. I don't know why Teams is refusing to mute everyone by default. Let me go to audio settings. Okay, this is my audio settings. I don't know. I must find a different streaming thing. So it's an array of integers, right? And students forget that I'm gonna post this, right? I'm gonna post this so that for everyone to see. So if you're busy saying nonsense, whatever, it's going to be in the public. That's up to you. Your choice. Come on. Seems like this person has been coming and exiting. Hey, so it's an array of integers, but we're going to divide it up into one D array and one D array. So UJ, so whatever UJ board, right, will be basically representing an array of my rows. And then UJ board row will represent will represent one row, meaning that that row will store an array of columns. So hence we achieve the 2D array. And remember, I said an array of rows, meaning that an array of UJ board rows. That's why when I declare my array inside UJ board, it should be called UJ board row. But in my case, I'm calling it UJ chess row because I don't want students to just copy and paste code. They have a tendency of doing that. So since this is the logic, right? At each row, we have another array representing columns. That's why I'm going to come here and say T pointer for one-dimensional array. And then I'm going to call it, what am I going to call it? Values. I'll call it values, right? You can call it anything you want to call it. Let me just double check something here. Okay. So I'm gonna call it UJHS row, and my array is gonna be called underscore values. So I have the array, it's sorted. Now we can go to these two operators. So you must overload the single indexing operator. So let's overload that. So to overload the operator, use the operator keyword, which is gonna highlight. Then you pass the operator that you want to overload. And then you put round brackets to pass in how many parameters they should take. Remember, this is a single indexing operator, meaning it takes in a single index, right, or a single value, whether you want to get one column or one row. But since this class will represent an array of columns, that means I want to get back one column. So that means this user is going to give me a column to get a column, one column from my array of columns, right? Because each row manages an array of columns. So I could do this. The thing is, this one is called underscore calls, so I can't call this array underscore calls. So I'll just leave it as underscore values, but just know it's an array of columns. So this would be an array of columns. So when I index, right, what do I expect to get back? I'm indexing into the array. Everything in the array at each index is of type what? T. That means I'm going to expect to get back a type T, right? Remember, type T represents any type. If the user uses the chess row inside main, and they say they want a chess row of type char, it will come here and remove this T and replace it with the char. If the user creates another one and they say they want to use integers, it will come and replace this T with int. It does that behind the scenes, hence it's called a generic class. And since I might in the future want to change after accessing this column, I can return it by address, which means that I should be able to go to the address and make permanent changes. If you forget the address operator and you use this thing this way, let's say you have obj row inside main and you index, let's say you say index 0, and you try to use the assignment operator and say set it to 10, this is gonna crash if you don't return it by address. So you need to return it by address if you want to assign a value in the future. So I'm just gonna return an address because I might. So we have the double indexing operator. Then we should overload the assignment operator, meaning that I want to assign one UJ row to another UJ row. So that means I'm going to say operator and then equals to, because I want to overload the assignment or the equals to operator. You should take in another object that I want to assign to get a value from. So you see that it's actually similar to this. It's similar to a copy constructor because I'm copying one values from one object to another object. So basically, it's like going to the UJ library to use the printer and make a copy. That's in essence what we're trying to do here. Okay. Okay. In essence, that's in essence what we're trying to do. So I'm going to obviously, I'm going to take a UJHS row because I'm trying to make a copy of a UJHS row. That means I need to take another UJHS row to copy from. So I'm going to say obj, I also call it obj right-hand side because I'm obviously going to copy from the right-hand side. So remember, it's the same thing as the copy constructor. We take it by address so that we save memory, but we don't want to make permanent changes. We just want to copy the value. So I'm going to append a const there. And then after we've done all of these things, at this point, I think I should stop accepting students now, but it's fine. So we're going to assign, we're going to copy from a UJHS row, I mean, and we should get back another UJHS row as usual, right? So UJHS row, because if you're making a copy of a paper, you expect to get back a paper, right? Exactly. So I'm making a copy of a UJ row, and I need to get back another UJ row because I'm making a copy of UJ row. So obvious I'll get back UJ row. But I don't want to get back UJ row as a value because that will cost space. So I need to get it by address. But after getting it by address, I do not want to change that value. So I need to append a const there to say that after when you got back the UJHS row by address, I shouldn't be able to make changes to it. So I'm going to put a const there. And then that's pretty much everything you need inside this class. We are done with this class. Now we can implement it. So I'm going to also put a distractor, which is very important. That's the last thing that's needed here. So I'm going to put a distractor, UJHS row. There's the distractor. And I might, since I have a default constructor, I'm going to need default columns. So static const int default columns. I'm just going to use small columns because when you test these things, you don't want an array that's like 250 columns. That's big. It's not enough to, it's going to be too big for the screen and even too big for your markers to see whether your thing actually works. So I'm just going to say 10, size 10, and then leave it like that. Since I'm going to use the assignment operator and I'm going to use the copy constructor, I'm going to repeat a lot of code. There's going to be copying, deleting, and allocating, right? So copy, I'm going to need a copy constructor function, a constructor function, and a distractor function. I'm just going to call it what they do, basically. So it's going to be void. I'm going to call this constructor. Basically, it takes this code that will be inside of our constructors, since it's going to be repeated multiple times. So that means I need to pass in int calls, and then I'm going to have a function called copy constructor because it takes the same code within a copy constructor. So that means it must also take in the same parameter. So I'm going to take that parameter const UJHS row by address. And then the last one is the distractor. Remember the distractor, just like this distractor here, you see that it takes no parameters. Even this helper function shouldn't take any parameters. Then I'm going to copy everything here. And then I'm going to create an implementation file. So since these are templates, right, you're defining a type that C++ does not know. There's no such thing as T. There's no data type called T. So since there's no data type called T, you must create your own implementation file. So you must come here and say empty file. If you by mistake you say CPP file, you've done spiritual things. Your code is gonna crash dismally. So don't do that. So create an empty file, then call it UJHS row. So since we usually call it .cpp, I don't want it to call it the CPP because T is not a recognized type. It's just a made up name, right? To say that this class can take any type. So since I can't use .cpp, I need to make up my own extension. Like they've shown you in class, you're going to call it .imp, imp for implementation, because you're about to write implementation. Or you can just say temp for templates. That's up to you. So I'm going to call it imp and then save, click all, and then finish. And then I'm going to paste my UJ rows methods, but then I don't need these variables and this what is this constant. And then one thing about templates, right? You realize an error that you get very often. So on top of each method, whether it's a method or it's a constructor or a distractor, anything that belongs to that class, that's sort of like method, it's sort of like a method in a way. You need to always put that template type name on top of it, every single one of them. So that means on top of this parameterized constructor, I must put template type name T on top. Also on top of this one, also on top of this one, also on top of that one. And I realized that I made a mistake. Who's that now? Also, I realized that I made a mistake. Since UJ row is templated, right? That means everywhere I used UJ row, I need to put brackets like this symbols here, the less than sign and the greater than sign, because now this UJ row will be used like a vector. If you still remember vectors in first semester, I could you say vector, and then you put those symbols here, right? Because a vector class it uses templates, meaning that it can take in any data type. Hence, you can create a vector of chars, and you can create a vector of ints, a vector of shorts, a vector of anything. the same applies here. That means when I use UJ row, I use it this way, the same way as I've been declaring vectors. So that's the only mistake that I made here, so I need to fix that. So everywhere where I've used UJHS row, it needs to work, be used this similar way like we've been using it with vectors. So we have that, and then now we can implement. Let me see if there's no one here who's trying to use their audio, and I want to mute them. Okay, there's no one, which is fine. So, and here I'm not done. Also here, type name T, you need to pass that T there because UJHS row is gonna work exactly the same way as vectors. Only put this symbol here, the less than sign and the T and the greater than sign, only when you are returning or you are passing a type. Don't put it on destructors or constructors. Don't do that. It's only when you are passing it that the UJHS row type like this, or you are returning a UJHS row or a UJBOD row in your case. And remember what I said, on top of everything that you're implementing within UJHS row, you must put template type name T, like this. Template type name T, like this, and then template, come on, template type name T. And this is it's worth 20% in the semester test too. It's bonus marks if you use templates. So you get an extra 20%. So it's good to master it now and then use it in the semester test to get free marks. So like I said, the way you're going to use UJHS row is like this. So you're going to say UJHS row. This is another reason why we pass the template. So you're going to need to use it like this, UJHS row, and say that it takes in any type of, in this case, we called it T. If you remove this, right, the reason why we need to put it, it's going to say, what is T? It's going to be asking this question, what is T? So when you tell it T is actually a template type, it's a type name. How do we do that? We just append that template type name T so that it knows, or T is it's some data type, meaning it's any type. So yeah, that means on everywhere you need to declare it in that way. It's sort of like a different syntax, but it's still the same thing that you guys have been doing all along. And then remember, I need to fix this here to take in that, and then I scroll down. Yeah, one mistake, the code is gonna crash. And then here, like I said, every time we use UJHS row, we need to use it in that way because it's now generic. Even here, when you pass it, we need to tell it that it's now generic. It takes some type called T in this case. And then also here on my destructor, and then also here, and then on the constructor, and then the copy constructor helper method. And then I must not forget here, because this type is now the UJHS row now has a generic type, or it's a generic class. So we are done. Let's start implementing. So I'm going to delete, right? I know that my array, it's one dimensional. So I just only need to delete one dimension. How do I do that? I just say delete square brackets underscore values. And then I'm done deleting the array. Remember, when allocate this array, we're going to say is equals to new, and then you pass in underscore values calls here like this, right? To empty it out, you use the keyword delete, and then you leave this square brackets empty like this. But then the C++ syntax is that it wants you to put this square brackets before the array. That's just the C++ syntax for it. It needs to be before the array. And then set underscore values to null pointer so that it points to nothing. When we do this, we want to get this error code segmentation reference, a location that's non-existent. Hence, we set it to null pointer. So that when we get an error, we get a clear error called segmentation fault. And then the copy constructor, its only goal is to copy from this object. And this does a shallow copy. Why? You see right now that it does a shallow copy. Basically, it doesn't care if they're the same size. It just copies, which is a problem. So for example, you have a 2-liter container of Coke or Coca-Cola, and then you want to pour it into a glass. You can't pour the whole 2-liter. Why? Because the glass is smaller than the 2-liter. So the shallow copy, it's like that. It's like it doesn't care. So that means you have to stop at the capacity of the glass. You can't keep pouring even though when the glass is full. So you see, that's a shallow copy because there'll be some cold drink left in the container. So we need to do what we call a deep copy. Basically, we take in a container that's the same size as the Coca-Cola bottle, right? If the Coca-Cola bottle is 2-liter, we need to have a container that's also 2-liter, so that we pour out everything of the container. But then for now, we're doing what we call a shallow copy. So dot underscore calls. Why am I saying R? It's C. So I'm gonna call it C. So I'm gonna call it C and then C++, and then, so since it's one dimensional, right? I'm only gonna have one for loop because it's one dimension. So now I'm just gonna copy. So I've called my array underscore values at that index or at that position C is equals to my array from that object on the right-hand side. I don't know why people are just entering without muting. I don't know whether you think this is your father's place or whatever. Why are you not muting when you're entering the meeting? You're gonna disturb other students who want to actually understand what's going on. So let me continue. Come on. Can you guys please mute when you enter? So I'm gonna copy values from my object on the right-hand side. C, not R. So what's going on is I'm going to my object on the right-hand side and I'm taking the values from that array and copying them into the values on the left-hand side, which is the current array, right? So this is a shallow copy because it doesn't check if this array on the left-hand side is equals to this array on the right-hand side. So that means it's possible that I can have a glass, something that's the size of a glass on the left-hand side. And then on the right-hand side, I have something that's the size of a 2-liter Coke. So you see, they're not equal. That's why you call it a shallow copy. That means I won't be able to copy everything within the 2-liter of Coke into this glass. So we call that a shallow copy. So I have this copy constructor helper method implemented. Now I'm going to go to the constructor method. So we start by setting the number of columns inside of our class to the columns that we're getting from the user. Once we've done that, we now allocate the array and give it that size. Remember, since it's a one-dimensional array, usually it's like we used to do it like this, int, and then for each pointer we allocate a size, right? But then the array is no longer an array of ints. It's an array of t, meaning any type. So I need to say new t like this. And then since it's one dimensional, that means it's going to have one pointer. Then I replace that pointer or that star with square brackets to specify how big that dimension should be. So that dimension should be as big as the number of columns. And then that's it. You're done allocating here. And then I'm going to go to, let me see now, did I do the helper method? Yeah, seems like I implemented all the helper methods. Yeah, so now I can call the helper methods. So I'm going to go to my parameterized constructor and then call the constructor helper method and pass those columns that I'm getting from the user. And then the parameterless constructor, what I would do is I'll chain it. I'll basically go to this parameterized constructor, copy and paste everything that's there, which is just this one line of code, and then replace everywhere where calls was used with what? Default calls, because this constructor takes in no columns. Hence, we have to use our own default made-up values since we are not getting any value from the user. And then there's my copy constructor. So that means I just only have to call the copy constructor method. We just does a shallow copy, right? So it should take in an object, so I pass in that object right-hand side. And then that's it. And then I go to this indexing operator, a single indexing operator. I return my underscore values array. That array at which column? At that column that's being passed by the user. So this will be call. So this will get me back one column at that specific index, right? Or that, I know it's a weird way of naming it, but I'm gonna call it call. But this returns one specific column because remember, two-dimensional array, it's like this. So what I'm trying to do is I'm trying to go to that one. I'm currently at that row, right? And I want to get one column. Basically, maybe I want to get the column at column 0, or at column 1, or at column 2. So that's pretty much what's going on here. And I'm going to return it by address, meaning that I can assign it after returning it, meaning I can change it because we never know, we might change. And then there's the distractor. I'm just going to call the distractor helper method, which is just going to come here and copy and paste everything that's inside here. That's why we create helper methods, because we're going to repeat a lot of code. Because why? We have this assignment operator, which requires all three. So you see that we're going to repeat ourselves. So hence I created helper methods. So before I assign, right, or I make a copy, there's a lot of things I need to take into place. I must avoid reassignment, meaning that if the objects are already of the same value. So for example, if I have int a is equals to 10 and I have int b is equals to 10, then there's no need for me to set a is equals to take the value of b, because b and a are of the same value. So how do I avoid reassigning myself when it's already the same value? I just check the addresses of both objects. Remember, they're objects. How do I do that? I use this keyword because this keyword, what it does, it's actually a pointer, right? And it stores the address of this current instance, right? So by this current instance, it means that the instance that's calling the, okay, let me admit, normalize muting. Hey. So this operator, right? It requires this current instance. What do I mean by that? So for example, if you create UJHS row like this and say obj1, so this keyword is actually pointing to this address. So the address of obj1. So that's what this keyword does. It points to this current instance or this current object. So I'm going to check this current object, basically, which, remember, this keyword will actually refer to the object on the on the left hand side, I mean. And then we have the object on the right hand side. So we need to compare the addresses because this keyword stores an address of. So therefore I need to say, well, if if my address is not pointing to the same address of obj right hand side, then I know for a fact that these objects do not have the same value. So since I know that they don't have the same value, now I can copy. But I want to do a deep copy, meaning that I need to make sure the containers are of the same size. So the first thing that I do is I delete whatever memory was there. Whatever nonsense was there, I'm deleting it, right? So I'm going to call my distractor method, which basically calls the distractor code, right? And then after deleting, I make sure I allocate my object to be the same size as the object I am trying to copy from. Remember, I'm trying to copy from this object on the right hand side. So I need to make sure they're of the same size. If object right hand side it's 2 liters, right? That means the object on my left hand side should also be 2 liters. They need to be equal. How do I do that? I call my constructor helper method, which helps me to construct or allocate memory for the object. But what would be the size? It will take in my object's right-hand side's columns so that we become of the same size. Since now we are of the same size, now I can officially copy the values. So I can now transfer the values. That means all of the values will be transferred since I have allocated myself to be the same size as my object on the right-hand side. Now I just call the copy constructor method. So copy constructor, which takes in the object I'm trying to copy from, which is the object right-hand side. And then I'm done copying. And then I return this, but then remember I need to return an object so that I get the address of that object. So that means I need to dereference myself, basically point or go to this address so that I get the actual object. That's why it needs to be returned like in that way. So some people are brave. They're showing your faces. Remember this video, I'm putting it on YouTube. It's gonna be public. If you don't mind having your face there, that's cool. So it's gonna return this object, right? After, remember, I'm copying from one object to another. So I'm gonna return myself to double check whether the copying was successful. So I'm gonna return myself. And then I'm officially done with UJ chess row. Everything that's needed is done. It's complete. Now we go to the other class, which is a class that represents our actual chessboard, right? I could have called it UJ chessboard row, but that's too long. It's a very long name. I just called it UJ chess row. So that means my class would be called UJ chess, just UJ chess. You could call it UJ chessboard if you want to. That's up to you. So ujchess.h, I don't like the underscore included because I was taught by Prof. Coulter, just a habit that I picked up from him. And then I'm going to say class UJChess, right? So that's UJChess. And remember, this UJChess also needs to be templated. That's the problem. So we need to also put that template type name here. Type name T. Remember, this T can be anything. You can call it B, you can call it any type, but then after you call it any type, that means you need to use that name that you've given it. Hence, they just use a small name and call it T for simplicity purposes. And then I'm going to say public to list everything that should be public inside to the user, and then private to list everything that's private. Basically, only UJHS has access to that thing. So we have this. Let me go back to my practical and see which operators I need to overload. So bullet number 2, the UJ board should have one dimensional array of generic class UJ row pointers. First of all, how do you represent a pointer? So I have UJ chess row, so that's different in my case. That's what it's called. And since I'm going to use UJ chess row, I need to include the header file. So UJ chess row.h, because it's going to say type undefined. Basically, it doesn't know what UJHS row is. So I need to tell it that UJHS row is found within this header file. Go look for it inside that header file. So I'm going to say UJHS row, right? And remember, to create a pointer, it's like this, right? That's how you create a pointer. And this will be my, I'm going to call it underscore array. So this is my array, right? And remember UJHS row, what did we say about UJHS row? It's also generic. So every time you use it, you must pass it like this. Just like a vector. If you remember a vector, you can create a vector like this and say int and then call it underscore numbers like this, right? It's similar to that because a vector class is templated also. It's generic. It can take in any type. So that's what we're trying to do. We're trying to define our own data type that takes in any type. So that means every time that class is used, you must be passed in this. It must have this these three things: the less than symbol and T and greater than symbol. So remember, they said it should be a UJ chess row pointer. but a one-dimensional array of those pointers. So that means I need another pointer. So this pointer on the first pointer, this one, it represents that it's an array. And then the second pointer represents that it's a pointer. It's a UJ row pointer. So it's an array, a one-dimensional array of UJ row pointers. It's not, you could interpret these 2 pointers as 2D. That's up to you. But for this practical, they say that for the other pointer, leave it as a pointer itself. Don't allocate memory for it. Leave it as a pointer. So that means it will be a one-dimensional array of UJ row pointers. So since this will be a one-dimensional array of chess row, it should be, I know they said one-dimensional, right? But then at the end of the day, it's two-dimensional. Why is it two-dimensional? Because if you go to UJ chess row, we have the other dimension. Here, there's the other array. So it is still two-dimensional, but then we are doing it in a different way. So that means I still need those two sizes, the underscore rows and underscore columns. And then I'm going to need my constructors. They said put the constructors that you see fit, you see that they're necessary. You see all the necessary constructors. So I'll put all three, the no args or the parameterless constructor and the parameterized constructor, which basically takes in the rows and columns, right? And then the last one is the copy constructor, which takes in a UJ chess, right? OBJ. I'm gonna normalize, call it right hand side, because I'm always gonna copy something from the right hand side and put it into my variable on the left hand side. So I'm gonna take in a UJ chess and I'm gonna name it OBJ right hand side, but it might be too big. Imagine like trying to send a file that's like 2 gigs of space, right? Or you shouldn't, you could avoid sending that to whole 2 gig and then just tell the user to go find it where it's stored. So basically go to its address, right? But when they go to this address, that means they have the access or the privilege to be able to make changes. But we want to prevent the user from making changes, since they should just copy from the array. So that means I'm going to append a const there to say leave it in constant form, the way you found it. I know this should give you the ability to change, but const now prevents you to change. So that now it makes our application fast. So we have the necessary constructors, we have the 1D array, we are done. And you must overload the single indexing operator. So remember, we have now an array of UJChess rows, right? So that means I'm going to get back a UJChess row like this, but then remember it's a generic UJChess row. And then operator, single indexing, which takes in a row, right? So this operator will help me return a row that I've created a whole class to represent my row called UJHS row. But then UJHS row, it's generic. And another important thing that we always talk about is that if you return it like, okay, in this case, not really necessary, but if you return it in terms of like this, that means you're returning it by value. Meaning that if you use this operator like this, you say, let's say you have a UJHS and you called it OBJHS, right? And then you say OBJHS. Remember, imagine this is inside your main. Then you say at row 0, get me that at that row 0, get me that specific UJHS row. If you try to use this assignment, your code crashes because you are getting it by value, not by address. That means you don't have privileges to make changes. So I'm going to return it by address because I just might need to make changes. So it's going to return a UJHS row by address. And then it's going to take in a value to index into that specific row because I have an array of rows and I want to get back one row. And that array of rows at each index has an array of columns. So keep that in mind. And we need to overload the stream insertion operator. So remember the stream insertion operator or stream extraction, they always need to be overloaded as non-member functions. And if you read your textbook, non-member functions are declared at the top before you do anything. Then at the below, you have your public, private, all the other things. It needs to be declared as a non-member function. And then, so that means you need to use the keyword friend. So it's like a friend. You're not like really part of me. You're your own external thing, right? You're just a friend. But remember, friend functions, they have access to private member variables, which is true because as a friend, your friend has access to your secrets, right? Which is private to you, right? It's the same concept here. So I'm not going to say using standard namespace. I'm just going to say standard O stream. But then the O stream is inside the IO stream. So I'm going to say hash include IO stream, basically input output stream. So IO stream, I'm going to return it by address just to make things faster or just to make sure that I can make changes in the future after using the streaming session. And then I'm going to say operator, and then I put the stream that symbol, which is two less than signs, and then it takes in two parameters. So you have a O stream objects, which is going to be on the left hand side. So that'll be, I'll call it OL, let me see. I'll call it OLHS, basically meaning that it's the O stream on the left hand side, which is true because it's going to be on the left hand side. So OLHS. And then it takes in a UJ chess. I'm going to call it OBJ right hand side. Yeah, no? Okay, that's fine. So it's going to be called UJHS. And then remember, we shouldn't take things by value. The objects have a tendency of being way too big. So I'm going to take it by reference, but I'm only outputting the values, so I shouldn't be able to change the values. So I'm going to put a const there. And then the function is complete. But then remember, UJHS, just like UJHS row, is also generic. That means every time it's used, I must put that symbol right there to say that it's generic, it takes in any type. I also forgot to put it here. It's been a while since I've used templates, since you guys are just used to declaring the classes normally. So this should be declared in this way. And then what's the other operator? I think this is the last this is the other one, the assignment. So we're left with two operators. So overload the what is this called? Let me just check. I don't know what it's called. I forgot what it's called, but this operator overload it and it should be able to swap values in array randomly. It should be able to the function, the parameter to the function, right, should be the desired seed value. So it's a seed that must be taken in. So basically there's one parameter. And if you look at how they've used it, look at this example. Do you see an equal sign here? Nope. So that means it's going to be that's why they show you examples. So it's going to be void. It shouldn't retain anything. And then operator, what operator am I overloading? This operator here. And what parameters should we take? One parameter, which is the seed, right? Seed value to seed my random number generator so that the values are unique every time they're generated. That seed is important. And then an existing UJ board should be able to the assignment objects like this. Well, this is wrong. This line of code calls the copy constructor, not the assignment operator. This is wrong. This is a bad example. They should have just removed the EJ board and just said OBJ1 is equals to OBJ2. You can test it out for yourself. It does invoke the copy constructor, not the assignment operator. So we need to make use of the assignment operator, which is the same as, didn't I implement the assignment operator here? Yeah, we did, which is the same as this. So it's similar to that, right? So the only difference is that I'm working with the UJ chess here. not a chess row. So UJ chess, take it by reference as always because we want our applications to be fast, but I'm only copying the data. I shouldn't be able to mutate or change it. So I'm going to append the const there, and it should return a UJ chess. But then I keep forgetting UJ chess is generic. So put that there. It returns a UJ chess. It's generic. So I don't want to get the UJ chess as an object that's going to, it might be too big. So I'm going to go to its address. But when I go to this address, I shouldn't also be able to make changes. So I need to put a const there. So the full syntax would be like this. And then we are done with all of our operators that are required. Now we can start coding. So I'm going to put the distractor because we're going to obviously, you see these are pointers here. They're going to be heap allocated. I will explain heap allocated when I start uploading past papers. I just might host like I might just might stream on YouTube and we do past papers via streams. I just might do that. I'll decide. So UJHS like this. And remember this the way when you say that UJHS is generic, you only do that when you're either retaining a UJHS or you're taking in a UJHS. Do not, and I repeat, do not do spiritual things and come to next to the constructors and do this. This is spiritual, very spiritual. You are tapping in the spiritual realm here. You're supposed to be in the physical realm. Stay in the physical realm. Don't do the spiritual things. So these are all the things that we need. Let me think. Will I need? Okay, you don't have to do this, right? But you just might need to get the row to be able to get the rows and the columns. So I'm going to create accessors for that. So int get rows, and I'm going to append the const at the end to say that the code that will be written within these functions should not change my array. So hence const, because they're accessors. They're only meant to access, not mutate. By mutate, it means to change. We do not want to change. And I forgot to do something here before my code crashes. So since this is a .imp file, it's not recognized as C++ code. So you can't, hence we didn't create a .cpp file. So the way you include, remember we usually include data file. We usually say here hash include UJHS row, blah, blah, blah. This is .imp is not a recognized C++ file, so it won't be able to compile it. So now the way we include is vice versa. We include the imp file in the header file when you're working with templates. And you have remember everything in sequential order. You need to include it after defining that class. So hash include uj chess row dot imp like this. You include it in the header file. I know it's a weird thing, it's vice versa. Just remember that when you're working with templates. And then I'm going to say new file and then empty file because UJChess is also generic. So UJChess dot imp. The imp just stands for implementation file since I'm working with templates. And then there's my imp file. There we go. And then if you read your C++ textbook or the slides, the friend keyword should not be placed in the implementation file. It should only be placed upon declaration. That's the rule that you need to follow. Just like virtual. You don't put virtual in the implementation file, it's going to crash. Because I have this assignment operator. So I'm going to repeat certain things. Even here in the copy constructor, there's code that I'm going to repeat, which is going to be repeated here, that I'm going to type, which is going to be repeated in the assignment operator. So just like inside chess row, I'm going to have the constructor helper method, the copy constructor helper method, and the destructor helper method. So I'm going to call it constructor. So this, since here it's supposed to take 2 parameters, this helper method should also take 2 parameters. Int calls and then come on. then void copy. I just name it this way so that I remember that this function it mimics, or it has the code for my copy constructor. So I know that if I want to copy any from one object to another object, I just call this method called copy constructor. So obviously it mimics a copy constructor. So that means it will take in the same parameter as an assignment operator. Remember, assignment operator and copy constructor, they are the same. Assignment does a deep copy. Copy constructor does a shallow copy. That's the only difference. And then void destructor. Come on, my keyboard is tweaking now. So I'm gonna go here, and then just before the destructor, usually the destructor, I put it at the end. You don't have to, you can put it wherever you want to put it. Since I'm going to do, and remember including the header files, the files, it's in vice versa. You include it in the header file. So I'm gonna come here and include my ujhs.imp after declaring ujhs. You include it before. Remember, include just copies and paste this. So it's going to say, what do you mean by ujhs? UJHS does not exist because it's placed before you even made the class available. So that's why we put it after, so that we avoid those crashes. Okay, let me accept this person. Okay. Okay, let's continue. So your code is gonna crash if you use, like, remember UJHS is generic, right? So let me do this. UJHS, it's going to be generic like this. So if you leave it like this, right, it's going to ask you, what is T? It's going to say, what is T? So we need to tell it T is a template. It represents any type. So that's why on everything that we implement, on top of everything, we need to say template type name T. I forgot to also put this on the friend function. So remember, the friend function is a non-member. Okay, yeah, and then some people are going in and out. I think I'll stop accepting students now. They'll just watch the recording. So remember, the friend function is a non-member function. So that means you need to put the template keyword, that template on top of it. Since it's a non-member, so this template here applies to only member methods or member functions. So since friend is a non-member, hence we need to define its own template. You could still call it T again, that's up to you. But to distinguish from the two, I'm going to call it type. And then I come here and change this to type to distinguish from the two, right? To say that, so that the person reading my code knows that this is a non-member function. And then I'm going to go back here, and then I need to change this to type, that T to a type. And then I'm going to copy this template type name, put it at the top there, and then change this to type, so that there's a distinction between something that's a non-member and something that's a member. I'm going to see member function or member methods when I see a T. So I'm going to put it on top of every single method. Yeah, it's really annoying, but you get used to it. Okay, on top of the copy constructor, on top of the single indexing operator, on top of the accessor for my rows, on top of the accessor for my columns, on top of my indexing operator again, but then with round brackets, and then on top of my assignment, top of my helper methods, and then on top of my destructor. And then I'm going to go back here, and then I'm going to need to tell C++ that all of these methods are part of UJHS. So I'm going to put it right before the constructor or the function name, so that C++ knows that they are part of the class, like this. And remember, operator square brackets, it's actually the name of the function. Hence, I'm putting it right next to it. Remember the rule, you always put it right next to the name of the function, because the function is the one that belongs to the class. And the function is the thing that you came up with. If you put it next to our int and const, that's not yours. You don't own that. You didn't declare that. You didn't think of that. That's not your own. So don't do that. And then write operator equals to, that's the name of this function. And then we go here. And then for you guys, every time you make changes to your code, you must run it to test. With me, I can decipher my errors easily, so that's why I haven't tested anything. I know I might get some errors here and there, and we'll fix that when we get there. So the same thing here, we're gonna destroy, but for this code, it's a bit tricky to know how exactly to implement it. Why? Because we need to know how to allocate first before we can deallocate. This is a special case. We have a UJHS row, one-dimensional array of pointers. What does that mean? That means that each index or each row, we're going to need a new UJHS row. That's what it means. And remember, it's generic of type. And we could just use the default constructor, but we need to set our array and give it a value. So we're going to call the parameterized constructor by putting it like this, and then we pass in our columns. So at each row, just keep that in mind, at each row, we're going to allocate it like this. That's the difference here. And then let's start. Let me see. I think I can implement the constructor. Yeah. Let's start with the constructor so that we can see how to apply to write the code for the destructor. So for the constructor, it's simple. We start by setting the rows, which is pretty straightforward, and then we set the columns, which is pretty straightforward. And then now the problem comes. I'm gonna have my underscore array and say it's equals to new. And remember, it's a UJHS row, which is generic of type T. And remember, we have two pointers like this, right? Each pointer should be allocated memory. But in our case, we only want to treat one of the pointer as a dimension. The other one, we want to leave it as it is because the instruction the instruction says that it should be left as a pointer. So it should be a one-dimensional array of pointers. So I start by allocating for the far outermost pointer. To allocate for that pointer or for that dimension, you replace that pointer with the square brackets, then you provide the size for that dimension. So the size is going to be underscore rows. And then now I go through every single row, underscore rows r plus plus, come on, int r is equals to 0 underscore rows r plus plus. And then at each row, right? Come on. At each row, remember, usually you would say int like this and say underscore calls, right? But the way the requirement is that you should leave it as it is, treat it as a pointer. So that means at every single row, or at every single row, I need to allocate something that's going to return a pointer or an address. So as you can see, I've written the code here. It's supposed to be like this. So we need to actually allocate a new instance of chess row and use the parameterized construct so that we can actually pass the size of that array. And remember, UJ row, each row has a specific number of columns, right? So we need to pass the columns. So here I'm going to say UJ chess row like this, right? Come on. UJ chess, there you go. UJ chess row like this. And then that pointer, that pointer will actually be referenced via here. The thing is, I don't have enough time to explain everything now. We'll explain everything once I start doing past papers. So I'm going to remember when you use the new keyword, that means you're allocating memory on the heap. So it's going to create the new object on the heap. And the heap, whenever you use the keyword new, it returns an address of where that object resides on the heap. Hence, we leave it as a pointer because remember what pointers do? They store addresses. So I'm going to come here and say underscore columns because each array manages columns. So it's going to be like that. Okay, let me do this. Oh, okay, I thought the person didn't mute. So each row or yeah, each UJHS row manages columns. Hence, it's going to invoke the parameterized constructor. Remember, if I go back here, which parameterized constructor will be invoked here? This one. So I'm going to pass in the columns. You see, it expects columns. Hence, I pass in the columns there. And then you're done allocating. That's it. So now we know that at each row, we allocated a chess row. So we didn't allocate, we didn't use round brackets to allocate, right? Or square brackets, I mean. We allocated the whole chess row. So we need to have that understanding, which is it's very important because the same way you allocated is the same way you deallocate. So I need to go through all of my rows. Why all of my rows? Because at every single row, it was allocated to have a UJHS row. So I'm going to delete that UJHS row at every single row. So I'm going to say delete. And remember, I didn't use square brackets to allocate that type for every single row. So I'm going to omit them. If you do this, your code is going to crash because it's going to go here and look for those square brackets. It'll be like, where are they? I don't see any square brackets here. So whatever you've done is nonsense. And then it's just going to output errors all over the place. So I shouldn't put the square brackets. I'm just going to omit it. I'm still deleting as usual, right? But the only difference is that I omit the square brackets because I didn't allocate that pointer. I left it as it is. And then once I'm done, I know that the row array, right? Remember before that I gave it I make use of square brackets. So I must also delete those square brackets like this, or that memory allocated within the square brackets. And then I must not forget to set it to null pointer to basically point at nothing. And we do this so that we get an error called segmentation fault, which means that we went to a memory that was set to null pointer. Then I would know, oh, I'm trying to allocate memory that does not exist. That's why we put this null pointer to help us get this error so that it's a clear error. If you don't do this, it will just jam and it won't tell you, and it won't tell you what's wrong, which is a problem. So we always need to set it to null point so that when there's a problem, it gives us a clear error that tells us what exactly the error is. So now since I've implemented my distractor helper method, I'll just call it here. When this distractor is invoked, I'll call this helper method. And then the copy constructor one is the same. It's similar to that one, that side. So I'm going to say for int, so this is the tricky part now. It will trap you this thing if you don't pay attention and understand what's really going on. So dot underscore rows r plus plus. And then for int c is equals to 0, c is less than obj right hand side dot underscore calls c plus plus. There we go. And then we've went through all the rows and columns, right? We are done. So I need to say underscore array at that specific row and at that specific column. But then we need to understand that this is not a two-dimensional array of integers or a two-dimensional array of UJ row of RGB color or whatever. It's different now. So what happens? Let's separate this. Let me put that column there. What happens when I run this part here? That returns a UJ chess row. But then remember, UJ chess row is a pointer. So I need to dereference and go to that actual object or the actual UJHS row. After I've went to the UJHS row, remember the UJHS row, it made use of the single indexing operator, which is this one over here. So I need to make use of that, which takes in just one parameter. So after dereferencing or going to that address, because if I leave it like this, right, this is wrong. This actually just returns the address of where UJHS row is. I do not want that. I want to actually go to the address or point to the address. So I'm going to dereference or go to the address for simplicity, right? In order for C++ to understand, you always need to put the brackets like this. So now I have basically it's like this. It's like you have accessed UJHS row, right? This is you accessing UJHS row here. And then now you invoke the indexing operator for UJHS row to access one column. So hence this and this needs to be there. So now, in other words, behind the scenes it's like this, but then the syntax to achieve that is like this. So I hope that makes sense because remember this array is an array of pointers. It's a one-dimensional array of pointers. So that means we only allocate one of the dimensions or one of the pointers. The other pointer, we still use it as it is. Hence, I dereferenced here. I used it as a pointer because that's how I'm expected to, because that's also how I allocated it. Because at each row, it's actually a pointer. Remember what I said, UJHS row returns an address. So this, whenever this is used, it actually returns an address of UJHS row. But I want to actually go to that address. So hence I used here, there's the address, and then I dereference to go to this address to get the actual object. Then once I've gotten the object, I use the single indexing operator defined within the UJHS row, which is this one, which gets me back a T by reference or that column. And then after getting that column, I can now set. So this equals sign, right? This over here, this would fail if you didn't return this UJ, this T by reference, meaning that you want to make changes. Hence, I return it by reference. And then I do the same thing. I get that array again from obj right hand side like this, dot underscore values R C, right? But then remember this section over here, like I said, this whole section will return an address. So we still need to dereference. And to make sure C++ does not get confused, we always put the round brackets like this. And then we dereference or point to this address to get UJHS row. Then after getting UJHS row, we use UJHS row's single indexing operator to get that specific column. So we use R to get the UJHS row, which is the row. Then that row gets back a specific column, and then we eventually get back that, where's UJHS row? We eventually get back that T or that value. So it's a bit cryptic. I agree, but it's not too bad once you have an understanding of what's going on. So that means every time you use this underscore array R, you must always dereference point to it. So we are pretty much done with the copy constructor. So now I can go to my constructors, right? The parameterless constructor will just be chained. So chain to UJ to another constructor. But then that means I need to specify default rows and default columns here. So let me go back here and fix this. So I'm going to need to create constants. So I'm going to say static const int default rows. I'm just going to make it a small image because I want to be able to see changes. I don't want to make an image like that's 500 by 500 rows. 500 rows by 500 columns, that's way too big. You can't even tell whether your operators are working, even when you test them. So default underscore calls just equals to 10. Because remember the main point they're trying to check here, can you overload the operators? They don't care how your image look. It's not even an image. It takes in any type. So we have that, we have the constants. Then I'm going to say default underscore rows. Remember, .emp is not a C++ recognized file, so it won't autocomplete. You must make sure you make no mistakes. You make a mistake, yeah, you're going to pay for it. So, okay, students are still entering. I advise you just watch the recording, but it's fine. Okay, students, I've seen these names a couple of times. Like I said, I think, okay, from now on, I won't accept any new students. They'll watch the recording. So since remember here, I'm just going to write the code for allocating, right? Didn't I allocate here? There it is. So I'm avoiding to repeat myself. Hence, when I get here, I'm going to say constructor, and then allocate and say rows, columns, like this. Simple. It's what this does is going to go to this constructor, helper method, copy and paste everything that's there, and then replace the first parameter with these values here. Replace the second parameter with this value here, and then that's it. And then here, I'm also going to call a helper method called copy constructor, since this is my copy constructor. And then remember that copy constructor takes in an object. So it's going to take in obj right-hand side. And then this is the tricky part here. You need to understand what's going on. Remember what we talked about. This operator expects back an actual UJHS row. So I'm going to say underscore array at that specific row to get that specific UJHS row. So row like this, but then remember this returns a pointer in address. Does this function return a pointer? Nope. It expects an actual object. So I need to point at this address to get back UJHS row. So this should be like this. And then here it's simply returning underscore rows. And then here is simply returning underscore calls. And then for the seed, I'm gonna leave that. I'll do that later, the seed. And then remember the formula is you always check yourself. If you're not equals to the object on the right hand side, it means that the values are different. We only copy when the values are different. Hence, I said if my address is not equals to the address of the other object, then I can copy. But remember, this is a deep copy. I need to deallocate, so I need to call the destructor helper method to deallocate. So delete memory first, and then allocate memory as big as obj right hand side. Remember, I need my containers to be the same size so that I can pour everything that's in the other container or make a copy that matches. If you are making a copy of an A4, you must choose an A4 format, right? You can make a copy, or you can take an A4 and trying to make an A6 or A7 or whatever. It's going to be smaller than this, right? So that means some words might not appear, which is wrong. So it needs to be both A4 if you want to make a copy of an A4. So that means I need to now allocate. So I need to call the constructor, and it needs two things, the rows and columns. So I'm going to take my objects rows and my objects columns dot underscore calls. So now we are of the same size. Therefore, it's safe to now copy the values, to transfer the values. That means I can now transfer all of the values. So I just simply call the copy constructor helper method, which just copies from one object to another. What object am I copying from? It's object right-hand side. It's called object right-hand side. And then once I'm done, I must return myself. If you return this, it's wrong because this function expects you to return a UJHS. So I need to point or go to that address to get the actual UJHS because this function expects you to return the actual UJHS. And then we're pretty much done. Okay. Yeah, we're pretty much done. That was quicker than expected. So we're pretty much done. We left it seeding. So to seed, we're going to need this function, the header file for seed time, right? So hash include seed time. We need that header file because we need we need two functions, the rand function and the srand function. So I'm going to go back to my function, and then I'm going to seed the random generator function. It's simple. It's called srand, but I didn't say using standard namespace, so I need to specify that it's from the standard namespace. And then I'm gonna say srand, and then I just pass the seed. That's all you have to do. Remember, it's called seed. S here stands for seed random function. So seed randomization to make sure that every time we run the program, it generates a different randomization. If we don't seed it, it's going to be the same value over and over, which beats the whole purpose of making it random. So we always need to seed the random generation function. And then I'm going to say And to generate a random value, remember to generate a random value, you need to have a range. How do you find a range? The formula is simple. Let's say I wanted to find a range between 1 and 4. Basically the range will return how many values can you generate. That's what we call a range. So what's the formula? It's basically upper bound minus lower bound, but there's something missing, but I want you to see why it's important. So let's subtract and see. So exactly what would be the range if we count using our fingers? It will be one. Basically, how many values can we generate? It's one, the integer number one, the integer number two, integer number three, integer number four. So basically, you see, it's four values that we can represent. Hence, our range would be 4. So let's test out with this formula and see if we're going to get this 4. And then I'm going to say 4 minus 1, which gives me 3. So you see now this 3 doesn't match with this 4. We have a problem. So how do we get to 4? What must I do to 3 to get to 4? I simply add 1, right? Simple maths. But what is 1? 1 is the lower bound. So after this formula, you need to put brackets here to remember brackets specify that do this first. So after doing that, we need to add back the lower bound so that our range starts at exactly that starting point or it's at exactly that lower bound that we're given by the user. So 3 plus 1, this will just be 4. So 4 and 4 matches. So this is the actual formula for the range. And then to generate a random function, a random value, you call the random function, and then you use the percentage symbol, which is it's called modulus, to find the remainder. And then you pass in your range here. And the range is found by that formula, like this. So let's apply this here to ensure that we understand what randomization is. So R is less than underscore rows, and then for int C is equals to 0, C is less than underscore call C plus plus. Let's not make mistakes. And then you must do this. If you want this thing to always be unique and not to generate once, you must do it within the for loop. So what random value, what are we supposed to randomize? Look at what's going on. Let's see the explanation. Using the seed value, the operator function will then do the following. At each location, remember at each location, meaning at RC, row, column, generate another random location. And we're doing that, they said within this loop at each location, which means what does that mean? It means within the for loop, because at each location it's within the for loop. So we are on the right track, and swap the value stored in the current location and the other location. So how do you swap? So let's explain swapping before we continue. So let's say I have int a is equals to 10, and I have int b is equals to 12. And then I want to say a is equals to b, and then b takes the value of a. This way of swapping is incorrect. Why is it incorrect? Because if you notice something, I lose track of what the old value of a is. Because this line of code here, it means remove whatever was inside a and put the value of b. So that means here a will be equals to 12. And then here I'm taking the value of a, but wait, a is now equals to 12. So that means b is basically setting b to itself, because a is equals to 12, which is equals to b. So basically I'm just saying b is equals to b, which is pretty redundant, right? So before I transfer the value, before I change the value of a, I create a temporary variable called c. I'm going to call it temp to store the old, or let me not call it temp, let me call it old value, to store the old value of a before I change the value of a. And then I change the value of a right here, right? Now a is 12. So you see that I can't use a here because it has a new value. Therefore, now I need to use this old value of a like this. Therefore, now b is equals to 10. Now we've swapped successfully. So as you can see, we always need to create an old value before swapping. But before we do that, let's generate the random values. So they said it should generate a random location. What is the location? Remember, on a 2D array, it sort of like represents a Cartesian plane. We have X and Y, where in this case, X is row or R, Y is C or column. So that means I need to generate a random row and generate a random column. How do I do that? I need to find a range. How do I do the range? So I'm gonna find the range for my row and call it range. Okay, let me call it row range for my rows range, right? To find the rows range. How do I find the rows range? It's the upper bound. So what is the upper bound? What's the maximum in an array? And remember, since arrays are zero index, right? Arrays are zero index. That means my range will be from 0 to underscore rows minus 1, since they're zero index. And then my range for my columns will be between underscore cols minus 1. And then remember the formula, it's always the upper bound minus the lower bound. So that means it's going to be rows minus 1, which is my upper bound, minus 1, minus 0, which is the lower bound. And then the result of doing that, you add back the lower bound. So add back 0. And then we do the same thing for the columns. I know it's pretty redundant. It's a 0, it does nothing. But trust me, this formula, you might forget it. So just write it as it is. So that means the formula is upper bound, which is just rows minus 1, minus the lower bound. And then I put brackets there to say do that calculation first. And then you add back the lower bound so that you get back a random value starting at the lower bound. And then int call range is equals to same thing, underscore calls minus 1 minus 0. And then I put round brackets between this so that it does that calculation first, and then plus 0, which is the lower bound. And then now I have my row range and my column range. Now I need to generate the random row, because remember I'm generating a random row and a random column. So I'm gonna call it random row. Should I call it rand row? Okay, let me call it random row is equals to, remember we said we use the rand function modulus the range, or modded by the range. So I'm going to say standard, because I didn't say using standard namespace. So I'm going to specify where the range function is coming from. It's coming from the standard namespace. So standard range rand like this, modulus your range. Since I'm generating a random row, I'm gonna use the rows range. And then I go to my random column. I create a random column, call it random call, and then standard rand modulus call range. And then now we officially have the random row and the random column. And remember, this will be done repeatedly, multiple times, because they said it should be within the loop. So now I have two locations. I have RC and random row and random column. I have those two locations, random row and then random column. So I need to swap the values at those two locations. Remember what we talked about. You must have a temp variable or store the old value. And remember, chess is of type, okay, remember when you double index, we get back a type T. Don't forget that. When we double index, we get back a type T. You see, type T. After indexing again, we actually calling this operator within our UGHS row. So we get back a type T. So I need to store type T here. That's going to be returned, and call this old value. And then is equals to underscore array at that specific row. But then this returns back a UGHS row. Address. I do not want the address, I want the pointer. So I need to point to that UGHS row. And then once I've pointed to that UGHS row, I invoke its single indexing operator, which expects me to pass a column, which is C. And then Done. I've stored the old value. Now I can change that old value at this. I can change this value at this location is equals to this, but then it's basically equals to this, but then now the row and column needs to change. It's now random row, the random row that I found, and that random column that I've found, like this. And then after that, I need to also set this random location to be this current location where I currently am. But this current location has been updated. So therefore I need to use its old value, which I've stored here. Therefore, I'm going to say dereference. Okay, I'm going to say array at that specific location R, which is returning an address. Point that address to get back a UJHS row. Index using the single indexing operator to get back the actual value, which is T. Remember, when I call the single indexing, I get back a T, right, which is the actual value. But then remember, I don't want to change it RC. I've already changed it RC. I want to change it random row and at random column, like this, and set it to what value? To this value, but then this one has been changed. So I kept track of its old value. So I need to set it to old value like this. And then we've successfully swapped. And then that's all the code you needed. We are done doing everything. This is all you required for your practical. So now let's test out the different values, right? So I'm going to come here and say hash include uj chess. And then okay, let me try to create the instance, right? Remember, like vectors, you say vector, and then you pass in any type, right? I'll also do the same here. I'll say uj chess, and then I'm going to say it's a array of integer chess, or whereby I have a two-dimensional array of integers. I pass the actual data type because I'm now inside main.cpp, and then obj chess, and then let's test to see if we have errors. Okay, yeah, we have errors. Let's see what are the errors. UJHS row. What? Oh, I made a mistake. You see now I'm mixing up names here. Here it's called underscore values. So I'm mixing up names. My bad. I need to go back here. And then underscore values. And then let me see where else did I use underscore values. Oh, so I only made a mistake here. I don't know what happened there. Yeah, that's the only place I made the mistake. So I'm gonna build again, and then let's see here. I'm inside chess, right? Inside chess. Okay. Yeah, you see now I'm mixing up things. This is underscore array. You see me and mixing up my names. It's not underscore values, it's underscore array. I don't even need to check the document, the error. You see, even here, I'm mixing up my names, my array names. Let me see, underscore array. Sometimes I'm using it correctly, sometimes I was doing more spiritual things here. Oh, we're not done, my bad. We are not done. We haven't implemented the stream insertion operator. Sorry for that. So let's implement this quickly. So int r is less than my object on the right hand side, rows r plus plus, and then my object on the right hand side, columns. Obj rhs dot underscore calls. Remember, private non-member functions are going to be what is non-member functions that are friend functions they actually have access to private variables. Hence, I'm saying dot underscore. They have access, just like your friend has access to your secrets, which is private to you, right? But your friend has access to it, right? Or else it beats the whole purpose of them being a friend. So remember, it's going to be underscore array at that specific index R, but this returns an address, so I need to point to get back the actual object. and then I index using the single indexing operator defined within UJHS row. And then I'm going to put a space after every single value. And then into my stream, I'm going to insert a new line. So standard ENDL. And then it expects me to return an OStream object. And then that's pretty much all you have to do to output. Let's see if we have any other errors. What did I do wrong now? Oh, I need to say it's from this object. So I forgot to say that. So dot underscore, because it's a non-member function. So you need to reference everything via that object. Okay, so everything is fine now. Process terminated successfully. So we don't have any errors, right? So before doing anything, let's test out the stream insertion operator. So cout testing stream insertion operator. And then I'm going to output an end of line character. And then I can output my actual object now. So let's test it out. So cout obj chess, like this. So it's going to have weird values, right? Random values. Okay, I'm just gonna remove standard namespace. Why is it complaining? Oh, my bad. I need to say cout output then the standard, the new line character. And then there we go. Like I said, you're gonna have surprising values. Remember, we haven't initialized anything. So we need to now make use of the what is that thing? The double indexing operator. Let's test that out. So cout testing double indexing operator. So basically we're testing it out to set everything in our array to 0. That's it. That's pretty much what I'm testing it out for. Oh, okay, I need to output a new line character. So now I'm going to test it out. How do I do that? I just do a for loop. Remember, I have get rows accessor defined. So I'm going to say obj chess dot get rows and then r plus plus. And then for int c is equals to 0, c is less than obj chess dot get calls to get my columns, right? And then c plus plus. And then now I can test out the double indexing. So at rc, you see, I'm using the object and I'm using double in the indexing is equals to 0. Why am I setting to 0? Because this class is now works with integers. I've defined it to work with integers. And then after I've done initialize everything to 0, I output the object again to see if it did change. And remember, in order to use this assignment, every time you overloaded the single indexing operator, you must return it by reference. Even in UJHS, you must return UJHS row by reference if you want to be able to mutate or change it. And then there we go. Perfect. You see, now it has zeros in it. That means it's working. So before it was like this, and then now it's like this. And then now we can test our randomization, right? Remember, it's a void function or void operator. That means it's used in this way. And I'm going to use it exactly. I'm going to pass that exact integer that they've used today. So in order for me to see those changes, right? What I can do is I can use my double indexing operator to give my array a set of random values, right? Let's say I say 9, and I'm going to say start at index 0, 0, which is that top left corner. And then I'm just gonna, because I want to see that those values shifted, they moved around, right? So I'm just going to say at 1, and then putting it in weird locations, right? 3, and set it to 3, 2, 1, and then 3, it's 9 again, and then here at 1, 5, set it to 7, and then at 1, 7, set it to 9, right? Something like that. So now I can output my array. So what I would do is I'll output my array after I've set the values so that we can see it before and after. So that you see that the values are going to shift around randomly, right? Let me open my terminal again. So you see, there are the values. Now we can randomize them. So I'm going to say testing. So I'm going to say testing this invocation operator, right? And then I'm going to output an end of line character, standard end of line. So let's test it out. So I'm going to say obj chess. Remember, it takes in one parameter, which is the seed. So 1337, like this. And then now I output my object again. You see that the values will be randomized as expected. They'll be in random locations. So let's see. So you see 9 was at the corner there. It was here. Now it's in somewhere here. It's around here. It's in a random location. And then you see 7 was there. Now 7 is down there. So the randomization is indeed working. And it returns 0 to show that there's no error at all. Even in our deallocation, even in our allocation, everything's perfect. So let me see, what other operator do we need to test? Yeah, the assignment operator. So the assignment operator, right? I want you to understand this weird, but it's weird, but there's a huge difference. So if you say UJ chess like this, and you say, I'm going to call it OBJ copy, and say is equals to OBJ chess, you see that this actually invokes the copy constructor, which is not what you're trying to invoke. You don't believe me? I'm going to show you that it is true. I'm going to go inside my implementation file, right? Where I was implementing the copy constructor, right here, I'm going to do an output statement and say copy constructor is called. And then output an end of line character. And then I'm just going to run my code, right? You see that it actually invokes the copy constructor, not the assignment, which is not what you're trying to call. You see, copy constructor invoked. And if you invoke a copy constructor, it does a shallow copy, which is going to make your program crash. You see, now I get this error because it's a shallow copy. Shallow copies are not allowed. So how do I invoke the assignment operator? It's a subtle difference, right? To invoke it, you declare the object separately, and then you assign it separately. So obj copy is equals to obj chess. Now you're actually invoking the assignment operator. So I'm going to show you that it does invoke the assignment operator by going to my assignment operator and doing an output statement here and saying assignment operator is called. And then I'm going to append an end of line character. And then you're going to see that it does call the assignment. So let me rerun it. And you see it's a subtle difference, right? But you see that there's going to be changes. Let me see. Didn't I define a parameter? Oh, remember OBJHS is generic. So I need to, when I declare it, I need to say int like this. That's why it was complaining. So build, and then the error is gone. And then I'm going to build and run. And then there we go. You see, it's a subtle difference. You won't be able to tell the difference, but there's a subtle difference. And you see now when we do deep copy, our program doesn't crash. So there's the assignment operator called, which is very powerful. So now I can output my OBJ copy. But then I need to say testing assignment operator. So I'm just going to append an end of line character like this there, just to save time typing. So cout obj copy. You see that my obj copy is going to have this exact same values as obj chess. So let's see it. You see? Exactly the same value. Look at this row. Exactly the same. Look at this last row. Exactly the same. So the assignment operator is working. And then that's pretty much everything you're supposed to do. Yeah, that's pretty much everything. So you can now just go get your 100%. There's your main. You did everything in your main. You tested the functionality, which is fine. Then you can go get your 100%. So I will send the code. Oh, let me just upload the code. So you're gonna look. You see when you look at the video, right? In the under the description, the code will be there. There's a link that I'm gonna put there. So stop asking and DMing me that you want the code. The code is on the link there. He's gonna take it to your OneDrive folder, then just download. It's gonna be zipped. Just download, unzip, and then you see the code. So thank you for watching. I'm gonna send you the recording. Okay.